Hello everybody, I'm Ryan and welcome to my IRP. For this project, I chose to model COVID-19 data. I chose to look at COVID data because obviously the virus has been in the news quite a bit in the past year. After watching Brian's project earlier in the semester, I knew I wanted to design an interactive map using Leaflet for my project. Leaflet is an open source JavaScript library that allows you to make interactive maps in HTML. I wanted to design maps which would show which states have the highest COVID infection rates, the highest COVID death rates, and the highest COVID mortality rates. I also wanted to design models which would give us a better idea of what kinds of factors might cause a state to have a higher rate of COVID infection, death, and mortality. The first thing I did was load a bunch of different packages. You can check my HTML file to see all the packages I loaded. The next thing I did was load in the COVID dataset, which can be found on the CDC website. The dataset had a whole bunch of different variables, but the ones we are looking at are the total cases and the total deaths. Next, I read in the states dataset, which likewise has a whole bunch of variables, but only two were relevant to this project: population and population density. I suspected that population density would be highly positively correlated with COVID infection rate. I combined those two variables with the COVID dataset using the merge function. The merge function became a constant theme throughout this project. Anytime I merged two datasets, I did it by state code. Many of the datasets I used did not include the state codes. Fortunately, R has a built-in function that converts names to state codes. This is the state.ab function, which can be seen in the HTML file. This function does not recognize Washington, D.C., however, so you have to enter that one manually, but it beats having to enter all 51 manually. After merging the two datasets together, I created the infection rate and death rate variables by dividing total cases and total deaths by population, respectively. I also created the mortality rate variable by dividing total deaths by total cases. I then set about adding or creating other variables that I thought might be relevant. First was the way that state voted in the 2020 presidential election. I downloaded the voting results from Kaggle, took the percentage of each state's voters that voted Republican, multiplied it by 2, and then subtracted 1. This gave me a variable that I named Republican factor, and that reflected the way the state voted. The range of the variable was -1 to 1 inclusive, with higher values meaning the state voted more Republican. The next variable I created was called mask mandate and was simply a binary variable with 0 meaning the state did not have a mask mandate and 1 meaning they did. Next, I added some demographic variables. Once again, this data set had numerous variables. The ones I used were percentage of the state's population under 18, the percentage of the state's population over 65, the percentage of the state's population with a bachelor's degree, the percentage of the state's population that was female, and the number of veterans in the state. Now that all the variables were read in and prepared, it was time to build some models. I modeled the COVID infection rate, the COVID death rate, and the COVID mortality rate based on all the variables I included. I started out building linear models using stepwise model selection. Through these models, we find that population density, voting Republican, and the percentage of the population under 18 are positively correlated with the COVID infection rate, while having a mask mandate and a large number of veterans are negatively correlated with the COVID infection rate, all of which makes sense. As for death rate, we find that voting Republican and population density are positively correlated. Then for mortality rate, we find that population density and the female percentage are positively correlated. I also wanted to build a car model, but first I had to read in the shape files. If you have the Tigris package loaded, those will already be built into R. I did, so it's just a matter of defining the shapefile for the 50 states and then combining it with my pre-existing data set. I knew that this would be the dataset I would use to create my maps, so I converted the projection system to be the same as leaflets using the st-transform function. I then set about building the car models, one for each of infection rate, death rate, and mortality rate. For infection rate, our model indicates that voting Republican and the female percentage are positively correlated. For death rate, our model indicates that the female percentage is positively correlated. And for mortality rate, our model indicates, once again, that the female percentage is positively correlated. After I finished building models, I set about constructing the maps. I chose the color scheme at random, assigning red to the infection rate map, blue to the death rate map, and green to the mortality rate map. In all three cases, the shade of the color would be dependent on that state's value for the rate in question. The state with the highest COVID infection rate would be the deepest shade of red, for instance. Then I went about creating the pop-ups. For these three maps, I tried to include the variables that my models indicated were statistically significant. I also included population density and whether the state had a mask mandate, regardless of whether the model said they were statistically significant, because common sense would suggest that they are. Finally, we get to the maps. First, the infection rate map. As you can see, the Dakotas seem to have a problem on their hands, both being a super dark shade of red. A quick pan over North Dakota establishes that the state has had 102,639 cases, corresponding to about 0.133 cases per person. Not surprisingly, they do not have a mask mandate. Hawaii, on the other hand, is basically just colored white on the map. Its stats indicate that the state has had 28,483 cases, which comes out to only 0.02 cases per person. They do have a mask mandate, which helps to explain things to some extent, but I would also attribute the relatively low infection rate to them being on an island 2,500 miles away from the mainland. As for the death rate map, New Jersey comes up near the top with 24,389 deaths, or 0.0028 per person. This is a bit odd considering that they have a mask mandate, but they're also the most densely populated state in the Union, which our linear model does indicate is positively correlated with the death rate. Once again, our islander friends to the southwest come in at the bottom with only 459 deaths, or 0.0003 deaths per person. And then the mortality rate map. Our model suggests that population density is the relevant predictor here. Indeed, some of the densely populated states of the Northeast US region are deep shades of green, whereas sparsely populated states such as Utah and Alaska are closer to white. My guess is that the densely populated states have less space in their hospitals for those who are sick, and thus fewer people who are admitted to the hospital with COVID symptoms end up surviving. After all of this, I had the idea to also model the effects of vaccination on COVID infection, death, and mortality rates. The vaccine data was also available on the CDC website. After merging the vaccine data with the earlier data, I divided the total vaccinations by the population to get the vaccination rate. Because the vaccine was not widely available, I chose to focus only on cases from 2021 for this part of the project. This was done by taking the COVID data as of December 31st, 2020, and subtracting the death and case numbers from those on the original data set, so we are left only with the cases from 2021. The rest of this data set was constructed the same way as the original data set, so in the interest of time, I will skip ahead to model building. For the rest of this project, I chose to focus strictly on the variables that are directly related to COVID, those being vaccination and mask mandates. Linear modeling indicated that vaccination lowers the COVID infection rate with 89% confidence, lowers the COVID death rate with 98% confidence, and lowers the COVID mortality rate with 93% confidence. That sounds quite promising. It is less bullish on mask mandates, however, not finding them statistically significant in any model. Our CAR models, on the other hand, are 80% confident that vaccination lowers the infection rate, 95% confident that it lowers the death rate, and 95% confident that it lowers the mortality rate. The CAR model also doesn't find mask mandates effective. For the new maps, I used the same color scheme as before. Red, blue, and green for infection rate, death rate, and mortality rate, respectively. But for good measure, I made a fourth map modeling the vaccination rate in every state. I used the color purple for this map. For the pop-ups, I included the variable being measured in that map, both the absolute value and the percentage of the population. The predictor values included in the pop-ups were the population, population density, number of vaccinations, vaccination percentage, and whether the state had a mask mandate. Finally, we move on to the maps. The infection rate maps says that Rhode Island, Arizona, and South Carolina have high infection rates. Rhode Island does have a mask mandate. The other two do not. We will see how their vaccination rates stack up in the final map. Hawaii once again comes in near the bottom in infection rate. But once again, I chalk that up to isolation. Looking at the mainland, Oregon has the lowest infection rate, followed by North Dakota, who, as mentioned previously, didn't do so hot in 2020. Oregon does have a mask mandate, while North Dakota, as mentioned before, does not. Moving on to deaths per person, Arizona and Alabama lead the pack, while North Dakota and Oregon come in near the bottom. Alabama, surprisingly enough, does have a mask mandate. Moving on to mortality rate, Alabama leads the way with a deep shade of green. I suspect that state is behind the pack when it comes to vaccination of its people. Utah is close to white, so perhaps the opposite will be true. And finally, we look at the vaccination rate map. As expected, Alabama, Arizona, and South Carolina have not been doing the best job vaccinating their people, while the Dakotas have worked hard to fix the epidemic that hit their states extra hard in 2020 by being among the leaders in vaccinating their peoples. There are a few surprises, however. Oregon, despite having one of the lowest infection and death rates, has not jumped on the vaccine train yet as much as I might have thought. But since the mortality rate is more middle of the pack, it's possible that they simply prefer to mask up and social distance. Meanwhile, Rhode Island actually does have a solid shade of purple. This and their mask mandate apparently hasn't helped to combat their infection rate. Meanwhile, the state that has hit the ground running the hardest on vaccinations is New Mexico. Despite this, their infection, death, and mortality rates remain in the upper half. I enjoy building maps with Leaflet because it is relatively easy to use as our packages go, and it is pretty entertaining being able to highlight any of the polygons on the map and see the pop-up with all the state's relevant information come up. Drawbacks and limitations to Leaflet include that it can be laggy at times, takes really long to render, and because it produces an HTML output, it can only be rendered to an HTML document and isn't as easy to share. So if you're a fan of PDFs, as I am, this might not be the best package for you. If you want more information on coronavirus, you can check out its Wikipedia page or the CDC website, where you'll find more information than I could ever hope to give you. Thank you, and good evening.